Hello, everybody. Let's go into our second line of defense. Let's talk about our immune system again. So remember that our immune system exists because out there in the real world there are pathogens. And these are agents that can cause all kinds of problems when they interrupt our normal physiology or body functions. We talked yesterday about the first line of defense, and today we're going to talk very specifically about the second line of defense. What happens when some of that stuff gets into your bloodstream, into your body, past those first barriers and all that kind of stuff? A couple things to remember from yesterday. These are non-specific responses, which means these can target anything foreign. Now that includes if you were to, let's say, get somebody else's blood and their blood is a little bit different than yours. This could include getting an organ or something like that inside of your body that your body doesn't recognize, and so it just goes a little crazy trying to get rid of it. They don't... What did we call this yesterday? Oh, yeah, we called this the innate immune system. The innate immune system. And it involves a couple of different things. One is a fever. When you raise the temperature, it's possible that it can kill cells, including your own. So you don't want your fever to get too high or last too long. By denaturing proteins and enzymes and things like that. That's one of those responses. Number two, your body has lots of what we call phagocytic leukocytes. Leuko meaning white, and cyte meaning cell. Oh my gosh, these are white blood cells. People with leukemia make too many of these, and it kind of causes a lot of problems. Number three is the inflammatory response. You know, when something gets infected, it inflames. Let's talk about that today too. And then finally, your body makes these proteins that are antimicrobial, which means that they will attach to microbes like viruses or bacteria and trigger your cell to get rid of them. One of these kinds of proteins is called a cytokine. And it turns out that one of the problems that's happening with coronavirus right now is that the body produces too many cytokines. And as a result, their system gets flooded with these molecules that just attack anything and everything. And it causes all kinds of problems in the body. You don't want a too active immune system. You want one that works right. And too much isn't good. All right, so fever and antimicrobial proteins aren't really a whole lot to talk about. So today in our notes, we're going to focus on just these two things right here. So let's start off by talking about phagocytic leukocytes. So a phagocyte involves that thing that we've talked about called ingestion. Not ingestion, engulfing. And when it engulfs it, it then ingests it by bringing it into the cell and then using enzymes to break it down. So imagine that you've got, let's see, a little bacteria here. So this is a bacteria. And bacteria doesn't belong inside of your body. And how does it know that it doesn't belong inside of your body? Well, remember that all cells have on the outside of them little molecules that identify them. And we talked about these when we talked about our blood cells. And if you remember back to your blood cells, there's a name for these molecules. And these molecules are antigens. And antigens are unique to each type of cell. And so what happens is when these bacteria get inside of your cells, if these antigens aren't not inside of your cells, inside of your body, inside of your blood, these antigens are recognized as not belonging. And when they don't belong, that's a trigger for the phagocyte to engulf it and then do some stuff with it. So what does it do? Well, phagocyte is huge. Bacteria are really, really, really small. So phagocyte is real big. So this is a phagocyte. And what happens is that the bacteria, when the phagocyte recognizes that the antigens don't belong, the phagocyte will then start to change its shape to eventually completely engulf this bacteria. You can see, you might want to draw this in a series of steps here, but it completely engulfs this bacteria to the point, to the point where it is now inside of its own membrane inside of the cell. So those things that were extending out to surround and engulf the bacteria, let's draw another set of them up here. Oh no, not blue. Those things that engulf the bacteria that the phagocyte forms are called pseudopodia. Pseudo meaning kind of like false or not real. Pod refers to foot. You know, we call a foot doctor a podiatrist. So pod means foot. And so these are like fake feet that come out and serve to engulf this bacteria. All right, so now once this bacteria is engulfed, we call this a vesicle. You know this. A vesicle is anytime a membrane surrounds just something inside of a cell. What's going to happen is inside of the cell, a little lysosome is going to come over. Now, this lysosome is a very special vacuole because this lysosome contains digestive enzymes. So this lysosome then, this thing just came up. Okay, all right, here we go. So this lysosome is going to then attach to and merge with this vesicle that contains this bacteria, and it's going to dump all of its digestive enzymes into this vesicle containing the bacteria. Now, this pathogen, whatever it is, the bacteria, the virus, the whatever, can now start to digest and break down and destroy this invading thing. But it's not done there. Not only does this phagocyte engulf and destroy and digest these things, but it goes one step further. Remember those antigens that were on the outside of each of these cells? This phagocyte now takes those antigens from this broken down, digested bacteria, and this is really neat. What it does, this is so cool. Like, I can't believe it can do this. those things will then be transported and displayed on the outside of this phagocyte. And what this does, I mean, it's like it's snitching or something. It's really funny. And this is a trigger for the third line of defense of your immune system to kick into action. So in a sense, what it's doing is it's saying, hey, look out for these antigens right here. And then the body starts its third, very specific line of defense against these. All right. So these antigens right here are from the pathogen. Antigens from the destroyed pathogen. Okay. That's it for that one. So that was our number 2, phagocytic leukocytes. Let's talk now about the inflammatory response. I'll do this one in red. All right, so the inflammatory response is a very, very general thing. It has nothing to do with targeting anything specific. I mean, what it really is it's just a way to sort of attract a bunch of stuff to the area of an infection. And by attracting stuff to this area, perhaps fight it off without having to go into the third line of defense. Okay. So, the whole thing starts off with, that should be a 1, tissue damage. All right, so you've got some kind of damage to your tissues. You've scratched yourself, you've been stabbed, you've banged your arm onto something really hard, and you've got a mosquito bite. Anyway, all kinds of things. When that tissue damage happens, there are 2 kinds of cells. One is called a mast cell, and another one is called a basophil. Now, these basophils are a kind of white blood cell. They release a molecule that you may have heard of before called histamine. Now, you may have heard of this because maybe you've had allergies and you've taken antihistamines. Sometimes when you have too much swelling or inflaming, antihistamines really help to bring it down. Okay. The third thing that happens is the damaged cells release a molecule to attract leukocytes. Leukocytes are your white blood cells, remember, and these help fight off diseases. And so this molecule gets released, which then is a trigger for the leukocytes to start traveling through your blood vessels and your lymph vessels to get to that site of infection. Okay. Now, this inflammation that happens causes a lot of different things. You've got heat, you've got redness, you've got swelling. Sometimes there's some pain associated with it. And a lot of that is the result of this molecule right here, this histamine. What the histamine does is it causes capillaries to widen. This is called vasodilation. Vaso referring to the blood vessel, and dilation meaning that it's opening up. Think about when the eye doctor dilates your eyes, it makes the black part of your eye get really, really big and wide. Okay. So vasodilation when the blood vessel swells up, or not swells up, when it dilates and it opens wide, more blood flows through that. So you get more blood flow. Which is why you feel warm in those areas when you have an inflammation. Now, that vasodilation increases the permeability of the capillary. And this is really good because it allows extra fluid to be released to the surrounding areas. It allows the leukocytes to get into the capillaries and all kinds of things like that. But this is why, because you have this increased permeability and extra fluid can leave, this is why you get like swelling around an inflamed area. Okay, and then you've got all of these leukocytes coming in, and these leukocytes are going to do what they do. They're going to be start engulfing foreign things that are getting in and all that kind of stuff. All right, that is it for the second line of defense for today. Tomorrow we will go over the more specific third line of defense, which is a lot more detailed than today. All right, bye-bye.